A child slides down a slide with a 28-degree incline, and at the bottom, her speed is precisely half what it would have been if the slide had been frictionless. Calculate the coefficient of kinetic friction between the slide and the child. This is the free body diagram of the child sliding a slide. Here is the child, and this is the FG. This is FG perpendicular, this is FG parallel, and this is Fn. Now we have to write the force equation for the surface with the friction. Okay, so sigma Fx is equal to mg sin theta, that means Fg parallel minus F friction. This is for the frictional surface. Therefore, we know friction, to find the friction, we have to go for the y dimension forces. Sigma Fy is equal to Fn minus Fg perpendicular is equal to 0 because there is no motion along the y direction. Therefore, Fn is equal to Fg cos theta, Fg is equal to mg, therefore Fn is equal to mg cos theta. We know F friction is equal to mu Fn, therefore F friction is equal to mu mg cos theta. I substitute this value here in this equation and then calculate the acceleration. Now, when I substitute this one, mg sin theta minus mu mg cos theta is equal to ma, or a is equal to g sin theta minus mu cos theta. Now we go for the frictionless surface. For the frictionless surface, simply mg sin theta is equal to ma, because Fg parallel is the only force acting on the child which is pulling the child down. Okay, but when there is a friction, this force has the opposition from the friction. Therefore, we have to subtract the frictional force. I haven't shown that here because I'm using the same free body diagram for both. That is why I haven't shown the friction here. Suppose if we have to take the friction also into consideration, the friction will be in this direction because the Fg parallel is downwards, F friction is in the upward, the child is sliding down. Okay, when the object is sliding down, the applied force is in the downward direction and then friction is in the upward direction. So mg sin theta minus F friction is equal to ma. For the frictionless surface, sigma Fx is equal to mg sin theta is equal to ma, or a is equal to g sin theta. And here, to solve for the coefficient of friction, that is what we have to find out in this problem. The clue is given as at the bottom, her speed is precisely half what it would have been if the slide had been frictionless. So frictionless is equal to V frictionless is equal to V friction by 2. Now we have to find out the velocity. How to find out the velocity? For that I use the kinematic equation. Vf square is equal to Va square plus 2Ad. Here initially the object is the child is at rest and then it is sliding down with a velocity V. Therefore Va is equal to 0, Vf is equal to V, and D is equal to, because I'm finding out D, whether the surface is frictionless or with friction, the distance the kid sliding is same. So that is how I equate the values and then try to find out mu. Therefore, D is equal to V square by 2A from this kinematic equation. And then I will write V frictionless is equal to V friction over 2. Therefore, V square by 2 G sin theta, A is equal to G sin theta for the frictionless surface is equal to V by 2 whole square into 2G sin theta minus mu cos theta. That means I am substituting for A and also for V in this equation D. This is the D frictionless is equal to D friction. Okay, I am substituting those values and then I try to find out. Just by simplifying this one, I get mu value as 0.398. Here you see V square by 2G sin theta is equal to V square by 8G sin theta minus mu cos theta, or 4 sin theta minus mu cos theta is equal to sin theta. Just a simplification. Okay. Just by simplifying this one, I get the answer as mu is equal to 0.398. This is the answer for this question. Hope this helps. Thank you. Bye-bye.